Look at these trees. These trees are from the Witcher 4 tech demo, and I think they look amazing. They are super performant. They can run on a PS5 with 60 FPS with these kind of dense trees. They are skeletal meshes. They are voxelized at a distance. That's how you get the performance. And they will even move, you know, in a distance. So it's super cool. And in this video, I'm going to show you how you can import your own custom trees. Stylized, realistic, it doesn't matter, your own custom trees with this workflow into Unreal. We also have like a surprise at the end of the video, a super cool collaboration of sorts. This also took me a couple of weekends to like troubleshoot and find out why it wasn't working and everything, so please subscribe. So why do you even want these trees? They are nanite, so they will just work basically. You don't have to think about LODs or anything like that. They are skeletal. You have a new wind system that actually follows the skeletal, so it's much easier and more performant than the VPO wind system we usually have with the, you know, the foliage doing the same thing over and over. And you can do cool stuff with that as well, but it's super unperformant, so you have to disable it after a certain distance and so on. This is much more performant and much more complex. Super cool system. And we've seen it similar systems in like Alan Wake 2. I found a video some time ago, but I couldn't find it right now. But here's a PDF from the Alan Wake 2 tech something. So they have a similar like GPU-based skinning with all the foliage vegetation. And this came out like 2 years ago or something. So yeah, super cool. And I think Unreal was inspired by this, that you could do this on such a big scale, or I don't know how it went, but it's super cool that Alan Wake already did it. And I think they are Finnish based, so it's close to Sweden. So it's feels good. If you imagine like a tree that has a skeleton, you can open up like a bunch of gameplay possibilities with this. So imagine like a bending tree or something, and you can just have somebody climbing on top of the tree, and it will be pretty easy because you have controls of all the bones and everything. So like attaching sockets or whatever could be much easier than before, than recalculating the VPO distance of whatever, you know, destructible foliage, more interactable. For example, all the branches are instances, so you can like maybe cut off a branch or something much easier than before because you have controls of all the skeleton. Super cool system. So let's dive in. So this kind of started as like a personal weekend project. I spent all my free time the last couple of weeks and finally arrived at the solution. I debugged a bunch in Unreal. I followed the schemas. I did a bunch of things. I won't bore you with the details. I had like a couple of videos on it, like the process, and I've done much more outside filming this obviously as well. And I had some help with from Control in a Discord server. He sent me a working sample that works for him. He also figured out the wind system. That's another thing we won't talk about today. So thank you so much, Control. That way didn't unfortunately work for me as it didn't comply with the USD schema. So I bet like Epic in the future will kind of break that. I'm betting because they already have like a bunch of like silent errors and so on. But super helpful and super nice guy. But if we fast forward a couple of weekends and all my free time, then we finally arrived at something that actually worked with skeletal meshes. And following the USD schema did work, sometimes did not work. And you kind of need to have all of these things in the right order, in the right place. But I'm going to show you everything now step by step. All right, so let's talk about the solution. So first step is to download Unreal 5.7. I don't know if you need the source build or not, but this path, as I'm showing on screen here, this needs to be included into your environment variables. You can just go to search for environment variables, and this is going to pop up. And you can do it on the top here with the users or down at the system. Doesn't matter really. And then just add this to your location of Unreal 5.7. So I'm having it in the H drive here, UE 5.7, etc. So make sure to change that as well so it matches your configuration. So in this directory, just make sure that you have this file as well as this file. If you don't, you can copy paste them from the Unreal source build from GitHub, and I'll probably link something, or you can just Google like source build Unreal. Make sure you have these files, then you're good to go. You can do this with Blender. You can do this with other applications. I'm gonna show you how to do it in Houdini for now, and maybe I can create like a plugin or something for Blender. That would be good. Or if somebody else takes this video, and what you want to do is to just drop a configure primitive like this. Go down to schema, apply schema, and make sure you have NaniteAssemblyExternalRefAPI, NaniteAssemblyRootAPI, and NaniteAssemblySkelBindingAPI, because these are loaded from the environment variable that we just set. So these are loaded into Houdini now. And this will be the same for Blender, Maya, any DCC or DDC that supports USD, because this is a USD workflow. So we're gonna go from our application to USD into Unreal. When you export from Unreal outside in USD, these schemas, they are not imported or exported. So when you try to import the same file, won't work. So they're kind of breaking their own API as well for import export, which is great. And no documentation as well, but I've said that like probably 1,000 times right now. So anyway, make sure you have these perfect. Then we are going to set up a tree basically, because now you are configured with the USD stuff. So I'm gonna go back to my prepared tree here. So that's OBJ in Houdini. So this is basically like how to define geometry in Houdini. So if you're not sure about Houdini, it doesn't matter. Like think Blender, think anything else. So this is just a mesh of a leaf, nothing exciting. However, we need to make this a skeletal mesh. This is because if I go to Unreal here, and if I go to Procedural Vegetation Editor, Sample Assets, I go to any one of these, and we can see here instances. You can see we have a static mesh, but we also have the skeletal mesh. So if I open one of these, you have the root bone here. So this is super important because now we can control the leaf here. And this is how the wind works and how it actually attaches to the twigs and so on. And this took a long time to figure out. If we take a look at my import here, you have the SK character, but it's just my leaf here. It's really ugly, my working in prototype, but you can see we have the same setting here. I probably should have it point up as well. So it's a bunch of small improvements we need to do here. But we have the root bone, everything is working. We also have the working tree, right? So this is my amazing looking tree. I know we have all the joints. You can like turn them around. It's looking great. Everybody's happy. And if I search on for not that, but yeah, I guess that we have assembly. So here we can see we also have the instances with the SK character, my leaf. Okay, so if we begin with the leaf, so each leaf or each twig, branch, whatever you want to instance on anything, it actually needs a root bone. So if we take a look at this leaf, for example, for one of the prototypes or one of the examples, you can see it has a root bone and it's bound to this root bone. So this, for example, if I search for assembly as I've done here, you can see all of these actually have skeletal meshes, right? So I don't know if this also has, no, but you can actually nest them as well. So it's super cool system. So this is a twig, but it's bound to this one root. So you can actually make more complex shapes as well. And like you don't have to nest them if you don't want to, right? So maybe that saves some performance as well. This was actually something that took a long time to figure out, that you needed like a skeletal mesh even for each leaf. Now it's super obvious. Now we can go ahead. So now you know what we're trying to do here. So in Houdini, I have my really amazing looking leaf here, and I'm just adding a point here. It's a small point, small, and I'm going to rename it to root. So I have now a name root for this joint, because now it's actually a joint. And I'm just binding this leaf mesh into this. And now you can see we can deform it. So nope, if I select this, press enter, now we can rotate the leaf. The same as we did in Unreal. So from the rig doctor, it just converts it into a joint. This will be the same if you like bind it in, you just take a mesh and in Blender and you just bind it to one joint. It's gonna be the same, right? So now I have a skeleton here from the rig doctor, and we also have the skinned mesh. So this is the skinned mesh. And I'm also setting on the primitive level the name and part, and we have the leaf mesh out. So that's what's important right here. So we have the skeleton and we have the skinned mesh. That's it, nothing more. So this bone deform and stuff, that's only to kind of see if it's deforming correctly. So next part is to actually create our tree. So if you saw the last video, we created a shitty tree, or we created an amazing tree, and it was made with SideFX Labs as well. So that's something I'm using. Go to the GitHub and you can see how to actually install and download everything with SideFX Labs. So if I right click here, I have the labs, everything with labs basically. So I'm using their tree. You can see here, tree controller hierarchy, everything labs tree basically. Just to get something, you don't have to use that. You can make your own. You can use else systems. You can do whatever you want. So I just have this basic trunk with some noise on it. And this right output is the skeleton or curve. And this left one is the mesh. So here we have a trunk and I'm setting the name to be OS, which is trunk, and my tree / trunk. And this goes out trunk. I'm not sure if I use that, honestly. So maybe don't think about that. We also have the branches, and you can see here we are spawning the branches and they are going all over the place. And out from this tree branch generator, we are getting the curve. So this is the curve for the entire tree, and I'm resampling, I'm fusing them. So you can see here, for example, they are disconnected. So I'm fusing them based on a distance. I don't think we actually need to do this because we can instance each branch basically on top of the tree. Then you won't get like a super nice transition between them. I have some friends that have figured this out though, that I'm going to talk about later. So stay tuned for that. Then we are reordering the curve. This is necessary because I'm not sure what. We are renaming the root bone into root. So if we take a look at the points, you can see we have the root here. And then we have the rig doctor to create with all the joints. So you can see the name here. We have the root as root, and all else are called something else, like joint something, a number. Perfect. And here we have our skeleton. So this null here, we are going to import into Solaris, like Houdini's USD workflow. So take a notice of all the nulls I've like shown you before as well, and go back in the video in case you missed it. So these we are going to import into the USD context basically. And yeah, then we are binding this mesh using Houdini's bind. And this will be like the weight paint stuff you do in Blender or Maya or whatever. We're just doing it like procedural here in Houdini. Here we can see how we can bend. So if I take a joint here, we can bend, and you can see how it deforms correctly. So yeah, this is great. And if I take a lower one here, everything on top follows as well. So that's great. And we want our leaves, right? So I just, yeah, that's better. So if we go back to our mesh here, we have our tree, and we want our leaves. So right here we have our tree simple leaf, only the mesh basically. And we have this tree leaf generator. So that's also from labs. So this is gonna generate where the leaves can be. And that's great. But why are we not like including this in the skeletal and like binding them to the skeleton? And this is because we want them as instances. So we have this branches and the trunk, and we're binding it to the skeleton as like a character, as anything else. But the leaves we want to instance in this new kind of tree way as Unreal has done it. So how we're going to do that is using some USD magic in the import that Unreal can actually translate. So Unreal is placing all the leaves on top of the branches, but we still want to see how we can do our tree here in Houdini, right? So this is my this is my amazing tree I have right here, and I'm super happy with this tree. So I'm taking the mesh of all the leaves here, so only the mesh of the leaves, and I'm converting them to points. So these are all the points from the meshes. I don't think I get rotation here, but that's fine. I'm gonna fix that another time and it won't be an issue. And we are taking the skeletal from the tree, and we are just converting like a name here from the joint name and saying, okay, this is not called name anymore. This is called joint name. So we can actually see this in the geometry spreadsheet. We're doing something super cool here. So whenever we have all of our leaves here, we want to find which joint is the closest one in the skeleton. So if we take here, for example, this leaf, and it's probably this one, right? So we are transferring all the attributes based on a radius here. So all of these points now that are the leaves have a joint name that is the closest one. So if we see, yeah, you can see these changing basically. So that's super cool. So whenever we're gonna like bend the tree and so on, even though they are instances, they are going to follow the tree as we saw in Unreal here. So if I open the awesome tree here, So if I bend anything here, all of these leaves, even though they are instances, are actually following, which is super cool. And we're doing this with an attribute in USD, not by binding anything like we did with the trunk, for example, that we actually bound to the skeleton, like the regular character way, if you may. So yeah, so after that, we can skip this one. I'm just setting like the part is the leaf on all of these points here, and the name is leaf. That's it. So now we have the points leaf here, this null. So this is also an export. So take note of that. Yeah. So the leaves points we have the skinned mesh. It's this one. So this is skinned to the skeleton, right? We bent it before like this. So that's working. And we also have the leaf skeleton, which is only let me actually remove this. We have the leaf skeleton, which is one single root bone. And we have the leaf mesh as well. That's kind of it. So now we are prepared to move into the Solaris workflow. So the next step. Okay, so the next step is that we are moving into like the USD context. So Houdini has Solaris, which is the USD context. Blender and so on doesn't really have that. So make sure you check your like DDC or DCC, whatever it's called, your application, how it actually is working with USD. So it might be in Blender, for example, that you're actually just exporting with a script or something, and that's it. So if I go back here, we can see that we have the stage, and stage is the USD context. So if we begin with our leaf again, these are called lops as well, but it's not important. We are importing our character, which is just a leaf, and we have the animated pose, the rest geometry, and the pose. But basically, we're importing our leaf and the skeleton with this one node here. What's important here, and this is the same for any basically application that you're using for USD, is the hierarchy, as you can see here down below in the geometry spreadsheet. So you see that we have the character, which is the leaf, and we have a bunch of values and so on. And these are the ones that are important for importing into Unreal. So I'm going to talk more about that. So we have imported our leaf. We also have imported our trunk with the same SOP character import. So we have both of these, which is great. And if I expand this a little bit, you can see it because we set like the S at path and so on. We have all of these branches separately. We're not using that right now, but we could if in case we wanted to instance a bunch of things. So that's also super cool. We also have like the different primitive types, Xform, Skeletal, Mesh, and these are USD types. So these will be the same in Blender as they are in Houdini, Maya, whatever. So, and a quick note on that, for example, this instancer, that would be geometry nodes in Blender, for example. And you can check more. Blender actually has, I can actually show you right now. So if you go to this website, for example, if you are using Blender, you can actually see like the Xform and scope, what is that and how is that used in Blender. So the point instancer, for example, is geometry nodes. Yeah, so all of the like different applications have their own translated use case from USD. So to import, export, and to how to work with basic. So check this out if you're using Blender, and you might also get ideas for how to implement this in Blender. I think a Python script might be the easiest, but that will be for the future. Okay, so we have our trunk and we have our leaf as well. So if we just focus on the trunk for now, and you can see it by following the line basically. So we have our tree, and it's important with the root of awesome tree, and we have a skeletal root, and under the skeletal root we have the meshes, all of them, animation, and actually the skeleton, right? Yeah, okay, so we have our tree, and now comes one of the most important nodes here. So we need to define this top node here. So if I select this top one, you can see how it changes. So now it's a component, now it's the kind is assembly. So these are like USD attributes. So this needs to be assembly, it needs to be Xform, the primitive needs to be defined. It's already in Xform, but set it to define. And we need to apply this schema, NaniteAssemblyRootAPI. So if you remember, we have these three APIs that are imported from Unreal. So we need to use this root API, and this should only be on the root, as you can imagine. And this has nothing to do with trees roots, you know. it's the root of the assembly. So the assembly root needs to be on the top null or empty or whatever you're calling it. So great, we have done that. And all of these can be applied with API in Houdini or even in Blender and so on. So yeah, I won't say that anymore now. Then we have a edit properties, and this is only applied to this primitive /awesome tree. So that's the top one. We have the slash here, and this is the awesome tree. So what we're doing here is we are setting it to a skeletal mesh, and we are setting it to the skeleton. So we're applying Unreal Nanite Assembly Skeleton. We're pointing this entire root has the skeleton of this one, right? So we're setting the skeleton of this assembly to this skeleton. And we're saying, hey, this is not a static mesh, this is a skeletal mesh. And that's all you need. And how you do that in Houdini is by clicking Edit Properties. You can click here from USD, you can search for Nanite, right? And you can see that we already have these guys on the top here, but then you're actually just dropping them below here. I've already done it, so I won't do it again. And then you click Apply or Accept, and then these fields will pop up here. Cool. And then if we go to our leaf here, because after that we are merging with the leaves basically. So if we take the leaf side, then we are importing our leaf, perfect. And we also have this skeletal root because this is a skeleton. So if you're importing something and you don't have the skeletal root, you're doing something wrong. And you have the skeleton for the leaf, which is the one little joint. So here we have something interesting. We have the tree instancer, which is a leaf instancer, but whatever. We're pointing this to awesome tree leaf instancer, and we are also including these out points, if you remember all the points of the leaves, so not the leaves themselves. So we are taking this skinned leaf basically, and we are putting it on all of the points that we imported. So if we take a look at this, you can see that we have the leaves, and the rotation is wrong, but I don't care right now. We need to fix that obviously. So it's an external SOP, and I point them to the points, and I pipe in this skinned leaf. Everybody's happy, perfect. Then we do the same. We apply a API schema, the NaniteAssemblySkelBindingAPI to the leaf instancer. So this is just some magic, but you can see it down here, awesome tree leaf instancer. So the instancer itself needs to have this SkelBindingAPI because Unreal needs to know, like, yeah, this instancer and all of these points, what should they be bound to? You know, what we prepared, like each leaf should be bound to the closest joint basically. Yeah, then afterwards we're just setting the BindJointWeights here, and I'm just setting it to 1. You can do this like super granular and stuff. This one underneath here is called BindJoints. So what you want here is basically a string list of all the points. For example, we might have like 400 points here. So if all of them are bound to root, you should write root 400 times, with the separator of space or a string array. And the easiest, why I haven't written like root here or whatever joint name 400 times, is because I did this script instead. So this script is using this Unreal Nanite Assembly BindJoints, and yeah, it's basically doing what I said there. It's setting this guy with the correct closest point according to what we piped in with the points that we had. So I can just show you that in case you forgot. So if we go back to leaves here, you can see the joint name we have for all the points. So we're using this attribute to set these on all of the leaves basically. Cool. Everybody understand? Perfect. And yeah, so this is how this looks. So you can copy paste that. So here you find the joint name and you set this to this guy by doing this, and some more checks in case something goes wrong. Cool. Right. Then we merge. It's important also to have the correct structure in USD. So you can see here that we have the X form, like the top root node. Then we have a leaf instancer. Then we also have outside like the branch or the trunk skeletal root thing with all the meshes inside and the skeleton inside. And the leaf instancer here has everything. We have the Primvars, Unreal, Nanite Assembly BindJoints, and we set this to this full list, right? So leaf 362 is bound to joint 95. Great. Seems good. And yeah, that's also cool. Like, we don't need this to be the length of the same instancer. It could be 1.0. All of them are bound like the same amount, basically. The BindJointWeights, it can be a single one, right? That works. It can also be 413, and that will be the same as 1. But if you want to bind each leaf to multiple joints, you can have it like multiplied by 2. The length can be for the bind joint weights to like 826 in length, right? So you can bind each leaf to multiple, this one 90% and that one 10%, in case you want like smoother whatever. Nobody's gonna see that probably, but that's something you can do. It's supported by the code I saw in the code. So yes, know that. Cool. We merge and then we export. So when I export here, click save to disk. I also use flatten stage. It's probably good to flatten the stage. I'm not sure. If we go then to Unreal here, we take a look at our content and import. Let's see if we can import this guy. All right. So this was test for USDA. So USDA is a ASCII format, so you can actually open this with a notepad, for example. So this is the full file. So in case you need to troubleshoot anything, you can actually see here the uniform token, assembly mesh type, skeletal mesh, and the relation and so on. So this could be really good if you're developing like a plugin for Blender, for example. Please somebody do that. I don't know if I have the energy for it, because all the joints and everything. So, and it's not that much, you know, it's like 1,000 rows or something, lines, I mean. So you can do USDA or you can do USD, and that's more performance. So I'm actually gonna re-export it to USD. So test for USD, perfect. And we go to Unreal and test USD for, perfect. Import is looking great. I have not made any like changes here. So import, and it's working. So no, test for. I haven't touched materials at all. That's another step as well, but that's the regular like USD materials. But now you can see we have the SK character, our leaf. We also have the skeleton for the leaf, same for the trunk and like the branches. And we have our assembly, which is this one. So if I open up this one, you can see it was the same as before. And if I rotate this, you have all the leaves and everything is following. If I search for, you get 413 instances. I can double click this character and I can move this. Perfect. And it's also working with like voxel. No, it's done here, I think. Voxel. No, Nanite. Yeah, so shape preservation. Just press voxelize, apply. So now whenever we are far away, we are gonna get that voxelized look. So maybe I can even do it here. Yeah, you can see here. So it's supporting this voxel super performance thing. And that's also supporting like the skeletal, which is super cool. So yeah, that's kind of it. I also forgot to mention, so you actually need some settings in Unreal. So let me show you that. 2 things you need. r.nanite.allow assemblies needs to be 1, and interchange feature flags import USD needs to be 0. So change these in the default engine. So whenever you create a Unreal project, you have a config directory. So just go into that and double click on the default engine.ini and change or add these under, yeah, I don't think it matters where, but yes, add the basically. Yeah, renderer setting. So that's one thing. You also need to enable some USD plugins, but not all of them. So if I go to plugins, yeah, you can see here the USD core, USD importer. I don't think we need this. But these 2 at least. You don't want the interchange you open US, not that one. So that's it. So now we can actually drag out our amazing tree here. Test for skeletal meshes. Save, awesome tree. Wow, looking amazing, right? No materials, not anything. Cool. You can also open the schema. That's also a good thing to know. The one in Unreal Resources, etc., as you see here on the screen. And you can read more about like the root API we did here. So we set this mesh type to skeleton, for example, and we set the skeleton. You can also use this ExternalRefAPI, and this needs to be an absolute path inside Unreal. So you can point like this point, for example, this X form, because it only needs to be X forms, but now you know what an X form is. And this works great. So you can just use this if you want to. The nice thing about using USD instancers instead of separate X forms is that whenever you are including like this leaf, it just got imported, right? You saw how everything just worked magically. Whenever you're using the other one, like the ExternalRefAPI, you can point to a skeletal mesh that you already have imported, but in case you move that or something, everything will break. So you have to re-import that or re-export, re-import everything. And I don't think you can actually set this inside Unreal. So I don't use this at all. I think you can reuse this with the point instancer as well. So that might work. I just wanted you to know. And here you can see the SkelBindingAPI as well. Cool. So now for the really exciting part, Natsura. So what you're seeing on screen here is a screenshot from Unreal. Over the last couple of days, I've been in talks with the guys at Natsura, awesome people. They are kind of making a speed tree, but much better inside of Houdini. Super cool guys, and they are now already implemented with some of my help, which was super cool. This workflow into Unreal. It's super easy. It's like one press of a button, like everything we did now. With their plugin for Houdini. And I'm probably gonna make more videos about this because this is what I'm gonna use for my project. And I actually reached out to them like half a year ago after I saw George's presentation. So they implemented this like in a day now. And yeah, it's looking amazing and really similar to what the Witcher guys are doing. If you want like this super highly realistic trees that actually grows realistically, like you have the simulation part, you have the manual part, and take a look at their videos and the website instead of me explaining, because it's a super cool system. And it's more like a speed tree replacement, but you have the full power of Houdini behind it in case you want it. If you are more like artist oriented, it actually opens up Houdini in like a more simpler interface. So you don't have to touch anything Houdini if you don't want to. You can just play around with like the branches and all the stuff. You can actually download this today and try it out. Yeah, so I'm super excited for that. This is what I'm gonna use. Take a look at their website. Yeah, they have a bunch of cool stuff. So in case you don't want to worry about like all the schemas and all the things, just use this instead. They're really fast and yeah, super nice people. So make sure to check it out. So the next steps for me would be mainly like the wind working. That's only a JSON file. Control has this already working from SpeedTree. I'm not gonna use SpeedTree, but it's just a JSON file for the wind. So it's pretty easy, I think, to do. Like these procedural things that are included here is also just a JSON file. I think I'm gonna wait until Epic has released more documentation about this because I don't feel like reverse engineering that JSON file. It was pretty big. It's not that hard, but just take a look at these this data asset, for example, and you can find out the JSON directory here. And this is in kind of the same directories from this plugin. So take a look there in case you want to mess around with that, and you can probably get that working as well. And make sure to tag me or something if you do. Yeah, so that's kind of the future, what I'm thinking. You have everything you need to make custom trees. Maybe somebody can create a plugin for Blender. I'm not sure I'm gonna do it. And make sure you subscribe. This took a lot of effort, so please. All right, have a nice one. Bye.